Well, day one is in the books for implicit differentiation. Those hopefully weren't too miserable problems to work through. Today we're going to go a little more in depth and a little more complicated with our implicit differentiation. We're going to see a few other things happening today, like quotient rule and chain rule and product rule and some good stuff. So let's go ahead and start deriving with our x to the 1/2 plus y to the 1/2 equals 5. So I'm going to go ahead and find the derivative of this implicitly. We're going to use our rules. We have 1/2 x to the negative 1/2, just a basic power rule. Derivative of y to the 1/2, we have 1/2 y to the negative 1/2. I took the derivative of y, so we'll have dy dx tacked along with it. Then derivative of 5 is going to be 0. Again, remember, make sure you take the derivative of that right side as well. Now we want to go ahead and solve for dy dx. In this case, not too miserable. We're going to subtract that 1/2 x to the negative 1/2 and then divide by 1/2 y to the negative 1/2. So I'll step that out for us so we can kind of see what we've got. So it's going to equal a negative 1/2 x to the negative 1/2. I'm going to go ahead and divide by my 1/2 y to the negative 1/2. So dy dx, well, let's look at this derivative, what we've got here. So our 1/2 divided by 1/2, we know that that's going to be 1. Those are going to cancel each other out. We have negative exponents. We can clean these negative exponents up, making them positive by moving them from the numerator to the denominator and from the denominator to the numerator. A little bit of algebra 1 there. So we get the negative of y to the 1/2 over x to the 1/2. And that's going to be our derivative. Our next example, a little more complicated. A couple things that we could do with this, and it's quite up to you how you want to tackle them. Depending on how you do it, you should come up with the same answer that we have posted. So what do I like to do with this one? Well, I see I have a quotient. We could multiply this over to the 4x, and that would just give us some product rules. Personally, it doesn't matter to me how you want to do it. You tackle it the way you see fit. Both of them are going to work out the same way. So I'm going to go ahead and get rid of that quotient rule myself. Just makes our life a little easier, I think. And even more importantly, or more in-depthly, I don't know what the words may be, we're going to take this 4x and we're going to distribute it in. So I get 4x squared plus 4xy. And I think this is a little easier to work with instead of trying to do the quotient rule there. So my derivative of x minus y, derivative of x, we have 1. Derivative of y is dy dx. Derivative of 4x squared is going to be 8x. Now comes the doozy. 4xy. We have a product. We have x times y. So we're going to need the product rule here. That 4 is a constant. So what I like to do with that is kind of leave it hang on the outside. And that's going to give us then, derivative of xy is going to be x dy dx plus y times derivative of x, which is 1. Remember, we have the product rule, 1d2 plus 2d1. Now, I can distribute that 4 through. I'm going to bring my dy dx's to the left side and my regular numbers to the right side. So 1 minus dy dx equals 8x plus 4x dy dx plus a 4y. So I definitely got to get my dy dx's together. I'm going to subtract my 4x dy dx over, and I'm going to subtract a 1 to the right side. So all that in one nice clean motion, I get dy dx minus 4x dy dx is going to equal 8x plus 4y minus 1. Notice we have dy dx in both of these terms. I want to get it down to 1 dy dx. So what I'm going to do is I'm going to factor that dy dx out. So I get negative 1 minus 4x left over. That's over 8x plus 4y minus 1. I can then go ahead and divide by that factor that's being multiplied to dy dx. So negative 1 minus 4x is our denominator. Now we could go ahead and pull a negative out of this denominator and bring it up to the front, or multiply it to the numerator. So a couple variations that we could see we could see it as the negative of 8x plus 4y minus 1 over 1 plus 4x. We could also see that negative being multiplied through the numerator, so we could see 1 minus 8x minus 4y over 1 plus 4x, and any variation thereof. I just brought the 1 up here or in the front to make it a positive value to start. Again, it's really up to you and what the multiple choice is going to look like if it's on a test or quiz. Extended response, I would leave it up here and be done because you've answered the question. Our last one's going to be, again, another fun one. We have the square root of xy equals 2x minus y. With all of our radicals, we've always changed them to fractional exponents, so we're going to do the same here. So we have the quantity of xy to the 1/2 equals 2x minus y. We have a quantity to an exponent, so to find the derivative, we're going to use our chain rule. So we have 1/2 xy, decrease that exponent by 1, we get a negative 1/2. And then the derivative of xy. We did the derivative of xy in just that previous example, if you recall. So derivative of xy, we have a product rule. So we have x dy dx plus y times 1. Derivative of x is 1. That's something that's fairly common, and we're going to use that quite a bit in the days to come and on your tests, your quizzes. So I would suggest either starring it or making a notation. Derivative of xy implicitly is x dy dx plus y. We just kind of seem to see that quite a bit as we look into our calculus. So derivative of 2x is 2. Derivative of negative y, we have negative 1 dy dx. Notice we have dy dx in both sides of our equation. So we got to get these dy dx's over to this dy dx. It's not going to be fun and it's not going to be easy. So let's kind of think about what we can do. There's lots of things we can do. What do you see? What do you notice? So one thing that I notice is this negative exponent, we can make positive by taking it down to the 2. And that's going to look like x dy dx, if I can write it dx, plus y over 2 xy to the 1/2. And that's going to equal 2 minus dy dx. Some people think, oh, that's kind of ugly looking. And it is. But what now we can do is take this denominator and multiply it over to the right side. So I have x dy dx plus y equals the quantity of 2 minus dy dx times 2 xy to the 1/2. I can distribute this into this quantity. So I have x dy dx plus y is going to equal 4 xy to the 1/2 minus 2 xy to the 1/2 times dy dx. Now all my dy dx's are kind of independent of each other and all the other terms. So now I can move this dy dx to the left side and this y to the right side. That's going to look like x plus 2 xy to the 1/2 dy dx. And that's going to equal a 4 times the quantity xy to the 1/2 minus y. I lost my dy dx, didn't I? So I was thinking, where did my dy dx go? So there's my dy dx. Now I've got 2 dy dx's independent. I'm going to get it down to 1, so I can go ahead and factor out a dy dx. That's going to be x plus a 2 times the quantity xy to the 1/2. And that equals 4 xy to the 1/2 minus y. Go ahead and divide then by my x plus 2 times the quantity xy to the 1/2 on both sides. And I've got my answer. So again, these problems, they do get to be kind of nasty. They get to be kind of ugly. I think we can do them. If you need a little bit of help, please don't hesitate to ask. I'm here to help you. So good luck, enjoy, and play around with our implicit differentiation with a little more twists and a little more turns. Good luck, enjoy.